Hello engineers, am I audible? Yes, if may audible, please say yes. Hello. Yes, if my audible, please comment on yes. Hello. Okay, I think it is audible. Okay, so welcome. This is the third lecture of analog fundamentals. So in a till now we cover first lecture in this we have a network and we have a difference between network and circuit. Now we discuss about the resistor, capacitor, and inductor, where we discuss how it will be effect in your layout. Of course, you have a metal, so of course it have a property of resistors, capacitor, inductors, and we discuss in terms of VLSI domain. In a second lecture, we discuss you can design a fixed resistor by the help of polysilica, or you can design by the help of MOSFET. It depends on your application. Okay, if you want a tunable resistor, voltage control resistor, you can use a MOSFET. If you want a capacitor with the help of voltage control, you can use a MOSCAP. We cannot design a inductor from the MOSFET because MOSFET does not have any coil. It does not have a property of storing the magnetic field, but you can design by the help of MOSFET. We can say that you can use as a op amp, and that op amp have output with the dependency of x something v is equal to L di by dt, the relation in terms of v is equal to x di by dt, that x become an inductor. So we can directly design an inductor. We cannot behave like a MOSFET behave like an inductor, but we can design an inductor from the MOSFET. But of course, it will be very bulky. Similarly, you can design a resistor. It will be very easy by the help of simply voltage source, and you can define it R is equal to 1 upon mu n CUXW by L VGS minus VTH, and you can use basically that gate capacitor. Okay, so you can use that basic things. Now we are going for sources. So sources is why it is important in a network, in analog fundamental. So just think in this way, you have a BMW or you have a car, you have a engine, you have a everything, you have a that is lot of facility in your car, but you don't have a fuel, you don't have a battery or something fuel, so it will not work. Similarly, you have a resistor, you have a capacitor, you have a diode, you have a MOSFET, you have everything of the electrical components, but you don't have a voltage source or current source. So it will not work. So today we will discuss about the independent source and dependent source. And dependent source is very important as an analog circuit design, because we can say that this is the heart of the analog circuit. The dependent source is the heart of the analog circuit. So firstly we will cover independent source, then we will go for the dependent source. So let's start with the independent source. So I'm saying that okay, the independent source, the name says that these sources do not depend on anything else. Means you have a source, let you have a DC voltage source, you have a battery, you have a AC supply, you have a current source, or you have a MOSFET based current source. It is simply defined like you have a constant voltage or constant current. So they does not depend on anything. You just have you have a voltage source. You can represent in this way. These are the voltage source. They are not dependent of any other circuit elements. Just like you have a current source, you can represent the current source like this, or you can represent like this. These are the current source. They does not depend on anything else of the circuit element. So these are the independent sources. But what is the VLSI relevance of the independent source? So you can say that you have a power rail. You are designing a NAND gate, NOR gate, XOR by the help of CMOS logic, or you are designing an amplifier, common source amplifier, differential amplifier, op amp, ADC, anything you are designing in terms of analog or digital, you require a power rail. You require a VDD and VSS. The VDD or power rail is what? These are basically independent sources. They are not dependent on anything. Okay, so these are the VLSI relevance of the independent sources like a power rail or biasing circuit, just like a current mirror. We are using a current mirror for biasing the MOSFET in analog circuit design. So you can use a bias current in analog circuit. So that voltage bias, that is called a power rail, we are just explaining in this way, or you can bias with the current. Okay, they does not depend on any of the circuit element. So that's why we are called as independent source. They are independent. They are not depending on anything else of the circuit element. They are just a battery. They are just like a battery. So you have. Similarly, once you go for the dependent source, this is very important topic. Okay, and you must know what is happening inside this. Why you are using the dependent source. If you have a knowledge of the dependent source, you can analyze the analog circuit also. So dependent source, the name says that these dependent on another voltage or current inside the circuit, means that the source have a dependency of the circuit element current or voltage. Let you have another circuit, the circuit current or voltage will decide that dependent source element voltage or current. Okay, so that one line, the dependent source are not physical batteries. They are not physical batteries, but they represent active device behavior. Just think in this way, ki, okay, you have a voltage source, just like an independent source. You have a resistor and you have a resistor. Let this is R1 and this is R2, and these are the voltage V. And I am saying that, okay, you have a one dependent source. Of course, the dependent source always represent in terms of diamond. Okay, with that the dependent source, that representation is like a diamond, and I am just designing in this way. Okay, and just I am saying that, okay, this is alpha Vx, and Vx is the voltage present at this point, and let this is R. So what is happening? This Vx, this voltage of R2 voltage will decide the current, that is a dependent current source. This is dependent current source. This is voltage dependent current source. Why? That voltage will voltage, here is voltage and that source is current. This is called voltage dependent current source. Okay, the source is current and the dependency on the voltage, and voltage is present through R2. R2 voltage will decide that current source. So these are that dependent source. Of course, dependent source is very important. Why? Because if you talk about that amplifier, that amplifier you can't design with the help of resistor, capacitor and inductor. You have a supply, you have a R1 and R2. You can design anything from that, but you can't amplify the circuit. You can't design an analog circuit. You can't design that sensor circuit. You can't design a ADC circuit if you don't have an understanding of dependent source. Just like this, you can understand the BJT. In a BJT, that you have the current is IB, the base current you have, and you talk about IC. This IC is what? This IC is a representation, is IC is equal to beta IB. The base current is very small. The base current is very small in a BJT, but the collector current is very high because the gain factor beta is very high. It is near about 100. Okay. So this is the amplification of the current. The collector current is amplified with the factor of beta with respect of base current. So these are the dependent. This is current controlled current source, where the dependency of that current, the source is current, the output is collector current, and the input is base current. So you can think in this way, the dependent source is very important for the understanding. You can't design the amplifier or ADC or op-amp or anything of the analog circuit or the sensor without the dependent circuit. Just like resistor, capacitor, inductor will help you to design, to control the current, to store the energy in the terms of electric field, to store the energy in terms of magnetic field. They are useful, But if you are going for that amplification, if you are going for that current sensing, if you are going for that amplifier, without the dependency, you can't design it. What is happening here? The happening is here you are defining that this is a voltage, this will provide that Vx. Of course, let this is the voltage here. I am saying that okay, this is the voltage V. Vx should be less than that. Why? Because Vx will be divided, the voltage will divide with the help of R1 and R2. Vx is less than that. Vx will be what? V into R2 upon R1 plus R2. It is less than V. It never be greater than that. But the factor of alpha will decide what is the output voltage. The output is what? Vout is what? Vout is minus alpha R into Vx. If alpha into R is greater than 100 or 10, it will be Vout is more than that Vx. So this is the way that in terms of Vx it will be amplified. That will decided by the gain factor. So dependent source will help you to analyze the amplifier circuit. We have a different dependent circuit like voltage controlled voltage source, current controlled voltage source, current controlled current source, voltage controlled current source. We have a 4 type. Why? Because we have a voltage and current. So of course we can design a 4 types of dependent sources: voltage controlled current source, voltage controlled voltage source, current controlled voltage source, current controlled current source. So firstly start with a voltage controlled voltage source. So which type of symbol it is? That dependent source always we represent in terms of diamond shape, and voltage controlled voltage source means the source is voltage and dependency is also voltage. So that sources is voltage and the dependency also is voltage. That's why the representation is like this. If you know that op amp, the internal architecture of the op amp is like this. And we are providing the input voltage and we have a resistor, the input resistance, and let this is V in plus and V in minus, and there have a voltage, or you can make like this, and you have a resistor. This is your V out, and I am representing like this. This is AV into VI, and this is R out. This is internal architecture of the op amp. What is representing? The voltage is present, that is VI. This VI will be multiplied with AV, that will become a voltage source, that is dependent voltage source. That's why op amp is called a voltage controlled voltage source. And you know that in a ideal op amp you say that output impedance is 0. Why we are saying that output impedance is 0? If R out is 0, this voltage will be same for V out. If this R out is not 0, so of course it have a drop. Let you have a resistance here of the output. You are taking the output at this load RL. So this R out will drop. That voltage will be drop here. It is not the voltage present is AVVI. It will be less than that. That's why in the last class we discussed about the ideal voltage source. In an ideal voltage source, I am saying that the voltage does have an internal resistance is 0. Just think in this way, you have a voltage source that is dependent voltage source. If R out is 0, so it will be the voltage V out will be AVVI. That's why we are saying that in a op amp that ideally the output impedance is 0. That similarly this input impedance, this is infinite. We will discuss that why it is infinite. Of course, if it is infinite, so there is no drop. there is no drop, or let you have any resistance here. If the higher resistance is present, so there is no any drop. So they have a V in Vi is equal to V in plus minus V in minus. Okay, so this is the way you can understand that dependent source is representing your internal architecture of the op-amp, and that's why op-amp is called a voltage controlled voltage source. That source is voltage and dependency also voltage, and the dependency present through the internal resistance of that op-amp. So if you know the dependent source, you can understand amplifier, sensor circuit, current sensing, anything you can understand, because these will help you to analyze the circuit. Why? Because once you go for the non-linear circuit, MOSFET is a non-linear circuit, diode is a non-linear circuit, they are non-linear circuit. To convert to linear, there is a requirement of dependent source. So you convert the non-linear to linear, there is a requirement of dependency. The dependent source will help to analyze that non-linear circuit to linear circuit. Similarly, if you analyze this circuit, there is a requirement of dependent source. So that is one of that is voltage control voltage source. That is a op-amp, and that the symbol is diamond shape. Source is plus minus because this is voltage source, and that dependency on control is also voltage. That's why I am writing alpha V. Let's talk about current controlled voltage source. Of course, that symbol is diamond. This is current controlled. The controlled by the current, and the source is voltage. So of course, source is voltage and controlled by the current. I am writing in this way. That is a current controlled voltage source. You can think in this way, okay, if you know the trans impedance amplifier, they are using for a current controlled voltage source. Or you can design any circuit. Let you have a circuit in this way, and that this is a current I. This is a current I. The current I will decide what is the voltage here. That is, let is beta I into that resistance or something like this. You can design in this way. Okay, so that current control voltage source, that dependency on the current and source act like a voltage, and this is a best example of trans impedance amplifier. We will use that the trans impedance amplifier. It is act like V out is equal to R into I in. That I in is here and V out of this will be a alpha. Alpha is R. Let this is the way. That's the trans impedance amplifier. Okay. Now let's talk about current controlled current source. The current controlled current source means what? You are controlling the current and the source is also current. So this is also a diamond shape. And this source is current and the controlled by the also is current. That is called current controlled current source. Just like a BJT, I represent that BJT. The BJT example, you are using BJT in a current mirror. If you are designing a current mirror by the help of BJT, you will find that current controlled current source. Or I am just explaining in this way, you have a base current and you have a collector current. That IC is directly proportional to beta IB. The base current is your controlling current and the output current is your collector current. So your beat alpha is your gain factor and I is your IB and the source is IC. This is called IC is equal to beta IB. That BJT is a current controlled current source. Similarly, let's talk about voltage controlled current source. So if you talk about voltage controlled current source, you have a symbol like this, that is diamond shape. The source is current and controlled by the voltage. Let this is beta V. That's controlled by the voltage and the source is current. Let's talk about the MOSFET. In a MOSFET, that MOSFET is act like a voltage controlled current source. That input is VGS, the output current is drain. That's why you are writing ID is equal to GM VGS. That is called transconductance. GM is a transconductance. What is happening here? Just the drain current, the output current depends on the input voltage. That's why I am saying that trans. The input voltage will decide the output current. Okay, so here you have a VGS. This VGS will decide what will be the current ID on the dependent on the VDS. And if the MOSFET in saturation region, this VDS is not required. This is behave like a constant current ID. Constant current source. So this is a voltage controlled current source. So everywhere I am saying that in the place of resistor, capacitor, inductor, they are not useful for that, for this type of understanding of the amplifier, sensing circuit. For the understanding of the amplifier or op-amp or amplification or ADC, DAC, there is a requirement to analyze the dependent source. You convert your whole circuit in terms of resistor, capacitor, and dependent source, independent source. These dependent source will help you how much it is boosting from the controlled voltage or controlled current. And this controlling current or voltage is coming from the dependent of the circuit elements. This dependent source, it depends on the circuit elements. I am talking about the MOSFET. You have a MOSFET. If you talk about the small signal model of the MOSFET, you have a VGS, you have a current source, and you have a resistor. And this will be your Vout. And this will be your GM VGS. This is a small signal model of the MOSFET. This is a dependent source. And on the basis of the VGS, you can decide your output voltage. Vout is what? That is minus GM R0 into VGS. So you can analyze it. The output voltage will be the factor of GM R0. If GM R0 is greater than 1, then the output will be the amplifier of input voltage. If GM R0 is greater than 1, so Vout, if GM R0 is 10, that Vout will be 10 times of input voltage. If the input voltage is 1 millivolt, the output will be 10 millivolt in terms of magnitude. Otherwise, it is minus 10 if you are forcing this sign. So this is the dependent. So by the dependent source only you can analyze. If you have a resistor, capacitor, inductor, you can't analyze this amplification. Is it okay? So that's why the dependent source is very, very important. So I can say that in a one line, the independent source provides the energy. Of course, independent source is just like a fuel. It provides the energy to move your circuit, to provide the current in your circuit. But the dependent circuit will provide the intelligence of your circuit. You can understand what is happening, how it will be amplified, how can we sense this circuit. Is it okay? Just like if we have one example, you have a one car or you have a e-bike and you are accelerating. The accelerator will converting in an electrical signal. That will be your VGS. And the demand is what is the demand? That is the DC motor. That the factor will decide how much it will be face that RPM. So this is the way that dependent source is important. This is not only happening by the help of resistor, capacitor, inductor. So that's why that dependent source is feasible for you for analog circuit, I can say that if you know the dependent source, you can analyze that any analog circuit. Okay, so this is the very basic understanding of the dependent source. Please follow this. Please follow the dependent source. If you know, so it will be a helpful for analyzing the circuit. Once you, if you are good in amplifier, you convert all a circuit into a small signal model. If you are good in current mirror, you convert this into a small signal model. And if you are really good in dependent source, you can analyze in a 1 second. What will be the gain? What will be the power dissipation? Yes, you can. So what is the VLSI relevance of the dependent source MOSFET small signal model? The small signal model is converting by the help of dependent source. Operational amplifier, we design that. The operational amplifier, you design the architecture of the internal architecture of the op-amp is requirement of voltage controlled voltage source. If you are designing a MOSFET small signal model, you require a voltage controlled current source based circuit. So these are the requirement and these are the beneficial for you if you know that dependent source and independent source. Now we are going too much deep in the network. Of course, we will solve that KCL, KVL based question. So firstly, you have basic understanding of node, branch and loop. So let's start with the node. So what is the meaning of node? And everything I will connect from the VLSI. Nothing that simple a node as a 2 point is connected, that is okay. No. Always we will cover every part with a VLSI so you can better understand, okay, this is happening in a real world and this is happening in a layout terms. Okay. So please come with me that what is the node? A point where two or more elements are connected. I am just saying that you have a two element, this is one element, this is one element, and you are connecting this point where the two elements are connected, that is called node. It may be two, it may be more than two. That's why I am saying that a point where two or more than two elements are connected, that is called node. I am connecting Z1 and Z2 at the point, that is called node. And if 2 point at the point it is connected, that is called simple node. This is called simple node. If only 2 point connected at a, if two elements are connected at a single point, that is called simple node. If you are connecting more than two elements at a single point, that is called principal node. So this is called principal node. So we have a simple node, we have a principal node. The two elements are connected, that is called simple node. More than two elements are connected, that is called principal node. Everywhere it is requirement. So what is the physical significance in the layout in a VLSI? So the VLSI relevance is that every connection, every junction in layout is node. Similarly, think in this way, you are connecting one element and two element. Of course, you require a one point, that is called via, or anything you are jointing this part, you require the pin, anything you want, that is called junction. If I want to go from Lucknow to Delhi, maybe the junction is Kanpur. If I am routing with a different path, if I am going with a car, so it will be Agra. So of course we have a junction. So every junction in layout is node. Every junction, if you are the junction at which two or more than two elements are connected, that is called junction. Every junction in layout is a node. Every node has a capacitance. What is the meaning of capacitance at this point? So you are connecting two elements. So if you are connecting with two elements, you must require a metal. And if the metal is connected, let this is metal 1 and this is metal 2, and you are connecting two metals. Of course, they have a parasitic capacitance. We'll discuss in a part when we discuss the capacitor. Let this is metal 1. And this is metal 2. So metal 1 and metal 2 are connecting. Let this is signal 1 and the signal 2, or you can say this is one element, this is another element. You are connecting at this point. If you are connecting this point, it is not connected properly, of course you require a via, you require a junction. So you use a junction here for a connection. If you are connecting the junction, by the help of the junction you have a two conductor, and in between that silicon, if you are talking about the silica, let this is a black screen, this is a silica, and a silica you have a field oxide. If you are connecting two elements on a junction, that junction will behave like a capacitor. Why? Because you have a two conductors and in between you have a field oxide. If you have a field oxide that have a capacitance, that C is equal to epsilon A by D. So whenever you talk about that node, every junction in a layout is behave like a node, and if you have a junction, of course you have a capacitance. Yes, if you have a node, so you have a two metals. Let you have a white, that is a metal 1, you have a yellow. I am just signing it, there is not meaning that it is always metal 1 and this is also metal 2. I am just assigning that, okay, this is one plate, this is two plate, they are two conducting plates, and you have a, in between you have a fox, means field oxide. You have a fox in between that. So of course you have a capacitor, and this capacitor is called a parasitic capacitance. These are not physical capacitance, they are internal capacitance, they are unwanted capacitance. Whenever you don't want a capacitor and it is present, that will become a parasitic, or you can say the unwanted capacitor is present here. So whenever you connect two or more than two elements in a network, that is called node. If you are connecting two elements, that the single point is called simple node. If you are connecting more than two elements, that is called principal node. This is the terminology of network. But if you talk about the VLSI, in a VLSI, if you are connecting two points, that is form a junction, and the junction is forming in between two points, of course it will form a via or a conduction, or you can say that parasitic capacitance will introduce, and these parasitics will be unwanted capacitors. Why it is happening? Because two metals, it have a field oxide. If they have a field oxide, of course it will form a capacitor. So in a network, everywhere you have a node, just think in a layout term, it have a capacitance. If you have a node in your analog circuit design, in a layout will be a parasitic capacitance. It will form a parasitic capacitance. Let's talk about branch. What is the meaning of branch? We start with a node. Let's talk about the branch. If we are connecting any element in between the two nodes, let this is a one node and this is a one node. If you are connecting any element in between the two nodes, that is called branch. The branch voltage, let this node have a potential is V1, this node potential is V2 with respect of ground. With respect of ground, this voltage, of course that every node voltage will be in terms of reference node. You can't decide that voltage that is V1. No, of course you require a reference node. A reference node not be a 0 always, it can be anywhere. It can be 3 volt, it can be 4 volt, it can be any voltage. But of course you decide that the node voltage always be a reference node, that the reference voltage, and V1 with respect of this reference voltage, V2 with respect of this reference voltage. So I am saying that okay, you have a node, one node and two node. This node have a voltage V1 with respect of reference node, that is, let this is 0 volt. So this is V1 with respect of this node, V2 with respect of reference node. So what is the voltage? The voltage will be V1 minus V2. If V1 is greater than V2, so it is a positive sign. If V2 is greater than V1, it will have a negative sign, means that sign is opposite. We are assuming opposite sign. Okay, it depends on V1 and V2 value. So the branch means what? Whenever you have a two node and the two node is connecting with an element, this element is connected with a two node, that is called branch. You can determine the branch voltage, that is V1 minus V2. You can determine the branch current. What is I? That is V1 minus V2 upon Z. That is very important when we talk about the KCL. Whenever you talk about the KCL, we have just, if you don't know that how it will be V1 minus V2, just think in this way. You have a V1, you have a Z, you have a V2. This is V1, this is V2, this is Z. Just use a basic loop if you know. That is I is equal to V1 minus V2 upon Z. So this is the way. In a one line you can say that I is equal to what? That you are saying that the current is flowing from V1 to V2. That's why I am writing V1 minus V2 upon Z. If the current is flowing from V2 to V1, I am writing V2 minus V1 upon Z. If the sign is opposite, it have a negative sign. So you just convert that sign. Okay, of course we assuming the current direction is like from left to right. So if the direction is left to right, that I am writing V1 minus V2 upon Z. Let V1 is less than V2, so it will have the current is negative. So I can say that the real current is flowing from V2 to V1, not V1 to V2. Okay, so you can, that is the way, the basic network. So I am just saying that what is the meaning of branch? A path connecting two nodes carry a circuit element. A path connecting two nodes. You have a two nodes. It have a simple node. It may be a principal node. It can be any node. I am just talking about the node. A path connecting two nodes carry a circuit element, that is will be a branch. Okay. So the branch, you can decide, you can determine a branch current. You can determine a branch voltage also. What is the VLSI relevance of the branch? So whenever you have an element in between the two nodes, of course it have a resistance. Every branch contributes resistance. You are connecting, let this is an element, and you are connecting this element with this X and this Y. In between X to Y, you are connecting this Z. Of course, you require a metal. If you require a metal, of course you have a resistance, because metal have a resistance, capacitor, inductor property. So if you are connecting an element in between two nodes, that will be a branch. And in the VLSI, if you are connecting here you have a parasitic resistance, that is unwanted resistance. You don't want it because you don't use a physical resistance, but if you are using a metal, it have a resistance, or that Z also behave like a resistor. So in a VLSI relevance, each branch contributes resistance. So this is the way you can understand, okay, what is happening by the branch, okay, what will be happen to in a layout. If you are a good analog circuit designer, you must have a basic understanding of layout also. If you don't know the layout, you can design a just an analog circuit. That is not a good way. Of course, you have a basic understanding of layout also. If you are a layout engineer, you must have a basic understanding of analog also. You must have a basic understanding of resistor, capacitor, inductor, current, voltage, dependent source, independent source, and how that capacitor is switching, how that capacitor is charging or discharging. Basic network you must know. Basic analog fundamental you must have acquired this. So if you are an analog circuit designer, you must have a basic understanding of layout, and of course you must be good in analog circuit, because this is your main stream. If you are an analog layout designer, you must have a basic understanding of analog circuit. Analog circuit means you have a basic understanding of network, so that the communication will be good. The analog circuit is design something and that pass to the analog layout designer, so they can communicate, okay sir, you can change this part, okay sir, you can change this part, so that layout will be easy. Okay, so that's why analog circuit and layout designer is very important for a IC designing. Okay, so this is a branch. Let's talk about loop. Any closed path, any closed path in the circuit, it will be a loop. So whenever you have a closed path like this, we have a voltage, we have an impedance Z1, Z2, Z3. This is a loop. If I am designing this one more, let this is Z4 and this is Z5. This is one of the loop, this is one of that loop, this is that bigger one is also one of the loop, but it is not, because this is not a closed path. A closed path means the current can be returned back. If I am saying that okay, that you have a loop, that means the current is flowing from this terminal to this terminal. The current have a closed path, then only the current can flow. So if this is following, then only you can say that there is a loop, or this is also one of that loop, or I can say that this is also one of that loop. We have a 3 loops, 1 loop, 2 loop and 3 loop. This is useful for a KVL or mesh analysis. When we use a KVL or mesh analysis, you must have a basic understanding of the loop. Let's talk about Z4 and Z5, that this is not a closed loop. So if current is going in this path, so it does not have a path to transfer from Z5. So this is not a loop. We can't say that this is a loop. So node, branch and loop. Node, 2 or more than 2 elements are connected at a single point. That is called node. It can be a simple node, it can be a principal node. Simple node means you have only 2 elements are connected at the point. That is called junction. 2 or more than 2 elements are connected, it's called principal node. Simple node and principal node are very important. In a simple node, you will find that current is same, but in a principal node, the current will be differ. So in a simple node, in a layout terms, that at a junction level, you will find the capacitors. That is called parasitic capacitance. When you talk about branch, whenever you are connecting an element in between 2 nodes, that is become a branch. And the branch, you can determine the branch current and branch voltage. Branch voltage means the difference of 2 node voltage with respect of reference volt. Because the node voltage is always defining in terms of reference node. Please be important this point. The node voltage always be defined with respect of reference node. Without reference node, you can't determine the node voltage. So the reference node, that is ground or maybe anything. So it is V1 and V2. The branch voltage V1 minus V2 or V2 minus V1. It depends on what is the sign of that Vx. Similarly, if you talk about branch current, the current is what? That is the difference of voltage upon impedance. That will be your branch. Okay, and then after this we are talking about the loop. So in the loop, we have any closed path in the circuit. It will be a loop. So it can be this part, this part, but the white one is not a loop because this is open. The current cannot flow by this path. So that is not a loop. What is the VLSI 11? Closed current. The closed current path. The closed current loops cause inductance. Why? You know the mutual inductance. You have this path and you have this path. So of course it have a mutual inductance. Or I can say that okay, you have a current, in a simple terminology, and you have a voltage here. This have a voltage, this have a current I1, this have a current I2. That I1 and I2 will pass through this resistor in the middle one. That is following that mutual inductance. So closed current loop cause inductance. So it can be a problem, but it is not that much because it is happening for a high current. We are not using an analog circuit design. We are not using that much amount of current. Okay. So the inductance part is not very important for you. If you are going for higher power electronics. If you are going for power electronics, you will face this part, because that if the current is flowing, it have a mutual inductance, it have a magnetic field. It can be emphasized the another circuit also. So this is the way you can analyze the part. Okay. So this is very important points. Let's start with a very basic thing. Okay, you have a voltage, you have a resistance. I am just generalize the interview questions. I have a voltage, I have a resistance, you can determine the current here. What will be the current? That current will be I is equal to V by R. Yes, this is very basic. Okay, so basically that current is V by R is happening here. But if I am using a capacitor, what is happening? What will happen if this you have a voltage, this is a DC source, so that the DC voltage source is present, the DC current will pass, and the DC current is I is equal to V by R. That V is let 5 volt, the resistance is 1K, that is a 5 milliampere current is passing from this resistance and through the voltage source. Let you have a voltage source and you have a capacitor. What will happen? So as you know that capacitor is a DC blocking. What is that meaning? The DC block? DC block means the current is zero through this. Capacitor cannot pass a DC current. Okay, why? Because the relation of current and voltage is I is equal to C dV by dt. The capacitor voltage is what? V, because they are in parallel. We will discuss in the next class series and parallel. We will start that series and parallel, but before that we will discuss about the KCL and KVL. But for now, let's talk about what is happening here, why that capacitor is act like an open circuit in a DC voltage, and why we are saying that the capacitor is act like a DC block. Capacitor is blocking DC circuits, DC voltage. Why this is happening? Because if you have a voltage and you have a capacitor, the current is zero. Why? Because the I is equal to C d by dt. The current relation with respect of voltage, a voltage or current relation in capacitor is I is equal to C dV by dt. Just like in resistance, V is equal to IR. In capacitor is I is equal to C dV by dt. In inductor, that V is equal to L di by dt. So here that current is differentiate of the voltage. And what is the voltage here? This is a DC voltage. DC means a constant voltage. The constant differentiation of anything. D by dt of constant is what? Equal to 0. The differentiation of constant voltage is 0. So that's why I is equal to what? I is equal to 0. So if I is 0, this means that capacitor is act like an open circuit. Whenever you have a current is 0 is more, it means the impedance is act like an open circuit. And similarly in a loop, I am saying that okay, that you have a loop and current is not present. What is that meaning? That current is what? Current is 0 here because this is open. It is act like an open circuit. Of course, it have a open. Similarly, I am talking about this circuit. In a capacitor, the capacitor is act like an open circuit. Similarly, why? Because I is equal to C dV by dt. And if I is equal to C dV by dt, the constant voltage, the voltage is V, and the differentiation of constant voltage is 0. And the current is 0. If current is 0 is more, what? That meaning is this capacitor is act like an open circuit. And if you are going in terms of charge, so you have a positive plate, this positive plate have a positive charge is here, this have a negative plate, this negative plate have a negative charge is here. So and in this you have a dielectric of free space. So this is not flowing, the charge cannot transfer to each other. So what is happening, that the electric field is present. The capacitor store the energy in the terms of electric field, that E is equal to half CV square. But in terms of current, there is no current, because whenever you have a positive charge and negative charge, they are collide to each other, then neutralize, and the current can flow. But that here the loop is not closed. That capacitor does not provide that positive and negative will neutralize to each other. So in a DC, the capacitor is act like an open circuit. Why? Because the DC current is zero. The current relation in terms of voltage is I is equal to C dV by dt. The current is zero. So whenever you talk about the capacitor in a DC, it is always be open. It is always be open. This is the way you can analyze the capacitor, and this is very important, because once you go for that amplifier, okay, whenever you talk about the amplifier or something, you have a MOSFET and you are an amplifier. Let you are talking about the common source amplifier. You have a resistor, and you are using one capacitor, and you are using one sinusoidal signal. Let this is R1, this is R2, and this is C. What is the voltage? So if you're talking about this is VDD, this is a DC supply, and this is a sinusoidal AC supply. So how can you bias this circuit? Of course, this current is zero, because ideally the MOSFET does not have a input current. It is zero because it have a high impedance. Why it is high impedance? Because this is silicon dioxide that is act like an insulator. So of course it is, the current is zero, and it is act like an inductor, capacitor. So that current is zero. So ideally that current is zero. Of course, practically it have a current that is called very small current, that is called leakage current. So you have a VDD, you have a capacitor. In terms of DC supply, in terms of DC voltage, this capacitor is act like an open circuit. So if it is open circuit, so the current is not flowing through this path. So this is circuit is what the voltage will be VDD into R2 upon R1 plus R2. Because this voltage is parallel with the R1 and R2, and that VDD into R2 upon R1 plus R2, that basic potential division. This will be happen. Why? Because you have a DC voltage. So if you have a DC voltage, you can analyze this part. So whenever you have a capacitor and you have a DC voltage, always make a open circuit. It is act like a open circuit, it is not perfectly open. The word is very clear. It is act like open circuit. Why? Because the current and voltage relation in terms of capacitor is I is equal to C dV by dt, and if the supply is constant, so of course that capacitor have a constant voltage. So the current is zero. If the current is zero, means the capacitor is act like an open circuit, and it will observe maximum voltage across it. Is it okay? So you can think in this way, okay, you have a supply, you have a R1, you have a R2, you have a capacitor. So what is the current through a capacitor? If this is a DC voltage, the current is zero. And what is the voltage? The voltage will decide the R1 and R2. The voltage will decide by the R1 and R2, and the current through a capacitor is zero. Is it okay? So whenever you have a current is zero, you will find the maximum voltage. If the voltage is zero, you will find the maximum current through it. What is that meaning? I am just saying that, okay, you have a simple circuit. You have a voltage, you have a resistance, you have a resistance. Let this is R1, this is R2, and you have V. By the potential divider, VR2 is what? VR2 is V into R2 upon R1 plus R2. If R2 is very high, let R2 is infinite, or it is infinite means it is open circuit. If R2 is infinite, so you can use V divide by R2, R2 by R2, R1 upon R2 plus R2 by R2. R2 by R2 become 1. So this is V into 1 upon 0 plus 1. So this is V. So as large this impedance, as large you have a voltage. So the voltage will dependent on this resistance. How much the voltage will occur at that R2. So this is the way you can. Okay. So we will discuss next part on that. We will discuss Ohm's law, KCL and KVL. But till now we covered that 3 classes, and 3 classes is very important if you are interested for analog circuit design. If you are interested for analog circuit design or VLSI, you must have a basic understanding of network and circuit. You must have a basic understanding of resistor, capacitor, inductor in terms of layout also, in terms of VLSI also. And how you can make that resistor, capacitor, inductor in terms of MOSFET. MOSFET can behave like a resistor. MOSFET can behave like a capacitor. But MOSFET cannot behave like an inductor because this does not have any cycle, turns or magnetic field storage device. So you can design an inductor from the MOSFET by the help of op-amp or different things you can use. But the MOSFET cannot behave like an inductor. So this is the way. And then after this you must have basic understanding of ideal voltage source and ideal current source. Because whenever you have a talking about the current mirror, we have a basic understanding of ideal current voltage source. What is the meaning of ideal voltage source? What is the meaning of ideal current source? After this you will enter in a sources. Of course you have a resistor, you have a capacitor, you have an inductor, so you require a source that is called independent source. Independent source is a simple battery source. You have a battery source, you can use this battery source and you can use that sensor and taking the data and convert into digital form and process it and convert into a digital to analog converter and use as per your requirement. So you have an independent source to perform the circuit. Without independent source you cannot perform the circuit. So independent source is required. What is the meaning of dependent source? The dependent source will help you. How can you understand inside the circuit? The MOSFET, if you are using a MOSFET, you are using gate to source voltage, you are using a drain voltage at a VDD, and you can use a source voltage is 0. These are the constant voltage. But if you are looking inside the MOSFET, you have a dependent source. This dependent source will help you to amplify the signal. Similarly, if you are talking about the diode, in a diode is a non-linear device. But if you are going for a linear, you will find that the dependent source is present here. And the dependency is Vd upon eta Vt. So you can convert the dependent, always the dependent source will help you to analyze what is happening inside the circuit. MOSFET is just like a black box. It's not a circuit, it's not a resistor, it's not a capacitor. MOSFET is just like a black box. If you want to look into this, you will convert into a small signal model. And then you can analyze, okay, this is happening due to MOSFET. MOSFET is just a symbol. You just thinking that this is a MOSFET. This is a symbol. But if you are analyzing this MOSFET, you will convert into a small signal model and you find a dependent source. So dependent source is the heart of the analog circuit. And then we talk about node, branch and loop. Node is basically a point at which 2 or more than 2 elements are connected. If 2 elements are connected, that is called simple node. If more than 2 elements are connected, that is called principal node. The simple node and principal node is required for a KCL. We will discuss that KCL and node analysis, then we will discuss this part. And then we talk about branch and loop. Branch is basically if you are connecting any element between the 2 points. These 2 points are node. Of course, this node have a voltage, and the voltage always with respect of any reference node voltage. So you can determine a branch voltage or branch current. Then after we talk about that loop, any closed path that have a closed path, if the circuit have a closed path, that become a closed loop. By the node you will find the capacitance, that parasitic capacitance. By the branch you will find the parasitic resistance. By the closed loop you will find that inductance, and the inductance is very small, so that's why we will not talk about that much. Okay, so of course you have a basic understanding, then only we can go for network. So we will discuss how KCL and KVL, because KCL and KVL is important, because as per the analog circuit there you have a basic understanding how the current is flowing, how the current is in a CMOS inverter, the PMOS current and NMOS current is entering and leaving, and you have an output capacitor. How in a cut off that PMOS a current is passing from PMOS and go to the capacitor, and in NMOS when that you have an input voltage is high, how capacitor is discharged, how the capacitor is charged and how the capacitor is discharged. You must have a basic understanding of KCL. The entering current is equal to leaving current. So we will discuss that KCL and KVL Ohm's law by the next class. For now, thank you so much, and if you have any doubt, please comment on that on this video, so we can more improve that circuit and more improve your knowledge. Okay, so thank you so much.